This is page 2 of the polynomials problem set. Number 2, the graph represents the temperature in degrees Celsius of some coffee after Manuela has heated it. Write down the two variables represented by this graph. Okay, so there's time and there's temperature. Write down the initial temperature of the liquid after heating. So right after it heated would be at time 0, so that would be, it looks like it's about 100, doesn't it? Maybe 100 Celsius. Write down the temperature of the liquid 2 minutes after heating. So if we count 2 minutes, 1, 2, that would be here. So that would be about 35 C. Find the time it takes for the temperature to reach 68 degrees. Okay, 68 degrees is about there. So that's about what? Half a minute? 0.5 minutes. Decide whether the liquid reaches 22 Celsius during the 5-minute period shown on the graph. It's kind of hard to tell. I think you could say yes or no. It's kind of hard to tell if it's 22. Write down room temperature. Well, the room temperature would be the asymptote, right? It looks like it might be 20 or 21 or 22. It's kind of hard to tell, right? You don't know how fast it's going down, so you could put something around 20. Okay, in the test, it's not going to be such a small drawing, so. In a physics experiment, a ball is projected vertically into the air from ground level. The diagram represents the height of the ball at different times, okay? So write down the height of the ball after 1 second. Well, after 1 second, it would be right here. Height of the ball would be what? 40 meters, right? 40 meters. Find out how many seconds after being thrown the ball is at 60 meters. Okay, 60 meters is like right there, right? So 60 meters looks like it would be like halfway between 1 second and 2 seconds, so maybe 1.5 seconds. Write down the interval of time in which the ball is going up. Well, it looks like the ball is going up until it gets to there. So what time is that? It's about halfway between, let's see, it's about there, right? So that would be about halfway between 3 and 4, so maybe 3.5? 3.5 seconds. Write down the maximum height of the ball, maximum height reached by the ball. Well, that, of course, would be right there. That's 90, right? 90 meters. Explain what happens at t equals 7. T equals 7 is right there. Well, the height becomes 0 again. It starts out at 0, it becomes 0 again, so the ball has gone all the way up, and then it comes back down and hits the ground. So I would say something like ball lands on ground, something like that. Okay. Number 6, the temperature in degrees C during a 24-hour period in a certain city is represented by this graph. Determine how many times the temperature is exactly 0 degrees C during this 24-hour period. Well, that would be like how many times does the graph cross the x-axis, the 0 degrees Celsius line? It's twice, right? Twice. Write down the interval of time in which the temperature falls below 0 degrees C. Okay, so below 0 degrees C would be here. Write down the interval of time in which the temperature falls below 0 degrees C. So that looks like t equals 4 to t equals maybe 8.5. So 4 to 8.5 hours. Write down the time at which the temperature reaches its maximum value. Well, that's pretty easy, right? That's that, right? Now, they didn't ask what the maximum temp value was. They just want to know when you got there. So you'd look at the x-axis, right, which would give you 16. 16. 16. T equals 16 hours. Write down the maximum temperature registered during this 24-hour period. Maximum temperature registered. The maximum temperature registered is 5 C, right? Write down the times at which the temperature is 4 degrees C. Well, let's see. One time is about there, and one time is about there. So this time is about 12, 13. It's about 13, right? 13 hours. Oops, I wrote it in the wrong place. Oops, no, I did write it in the right place. And, no, I guess I am writing in the wrong place. Write down the interval of time in which the temperature increased from 3 degrees to 5 degrees. Oh, I see. I was looking at the wrong one. I was looking at F. Write down the time at which the temperature is 4 degrees C. So the answer to that would be 13 hours and 20 hours. Okay. Write down the interval of time in which the temperature increased from 3 degrees to 5 degrees. 3 degrees to 5 degrees. So that would be like from here to, oops. That would be from 3 to 5 up there. Okay. So the time, that would be about maybe 10, 11, maybe 11 to 12, 13, 14, 15. Well, maybe 11 to 15. Oh, that's here. 11 to 15. About. Okay, can you deduce from the graph whether the behavior of the temperature in the following day will be exactly the same as this day? Why? Well, let's see. Does this graph say anything about the following day? Well, if you imagine that this graph continues, then, and this would be the start of the next day, what would be the temperature at the beginning of the day? Well, it looks like it's going to be about 1 degree Celsius, right? What was it at the beginning of the last day? It was 3 degrees Celsius. So is it going to be the same temperature cycle? No, because the temperature the next day starts at 1 degree Celsius, which is a different temperature, right? Under certain conditions, the number of bacteria in a particular culture doubles every second as shown by the graph. Copy and complete the table below. Let's see. So if every 5 seconds it doubled, we could just like fill this in pretty easy, right? So like at 0 seconds, the total bacteria is 1. 5 seconds later, the total bacteria is 2. 10 seconds later, the total bacteria is doubled, 4. Then 15 seconds, it's 8 and 16. Okay. Write down the time it takes for the culture to have 6 bacteria. Okay, well, 6 bacteria. So 6 bacteria would be about like that. Okay, and then so you could estimate like 14 maybe? 14. Calculate the number of bacteria in the culture after 1 minute if the condition remains the same. Calculate the number of bacteria in the culture after 1 minute if the conditions remain the same. Okay, so how many bacteria in 1 minute? Well, remember, this is like 20 seconds here we have here. So in 20 seconds, it gets to be 16. There's 2 ways you could do this. You could like make the chart bigger. You put 20, 25, 30, 35, etc. all the way till you get to 60, right? And they just keep doubling. So you go 16, next is 32, next is 64, next is 128, right? So you'll eventually get to the number here. The other way you could do it, which is a little bit more clever, is you say, okay, in 5 minutes, it doubles. In 20 minutes, it multiplies by 16, right? And then you could say, okay, if it in 20 minutes multiplies by 16, then I'm sorry, not 20 minutes. This is 5 seconds. This is 20 seconds. So in uh, in 60 seconds, it would multiply by 16 three times, right? Because there's 20 seconds goes into 60 seconds three times. And so what is 16 times 16 times 16? It turns out to be, I think, 4,096. Okay? So that would be a little bit more clever. Okay? But you could also do times 2, just like 20 times, right? And then you'll get the same answer. Okay, that's it for page 2.